The end of life on Earth has always been a topic of fascination and anxiety for humanity. While our efforts to unravel the mysteries of the universe continue, the timing of Earth's demise remains uncertain. However, scientific research dedicated to answering this question is providing a clearer perspective. A research team from the University of Chicago has made significant findings regarding this issue. While the study doesn't pinpoint an exact date, it sheds light on the fundamental reasons for Earth's eventual end. The research focuses on the how and why of this process, rather than a specific date point. One of the most critical findings relates to the impact of the Sun's evolutionary process on Earth. The Sun is expected to become increasingly brighter throughout its lifespan. While this might seem beneficial initially, it poses a significant threat to life on Earth. The Sun's increasing brightness will disrupt Earth's carbon cycle, making it impossible for plants to photosynthesize. As plants form the foundation of all food chains within the ecosystem, their absence would render life unsustainable. However, this event is still a long way off. According to calculations, the Sun's brightness increase and its detrimental effects on Earth's life are estimated to occur between 1.6 and 1.86 billion years from now. While this is a vast time frame, it underscores the profound evolutionary impact of this process and the significant changes it will bring to Earth's life, ultimately leading to its extinction. The study highlights that this process is not the end of Earth itself, but rather the primary cause of the extinction of life on our planet. As the Sun warms and brightens, Earth's climate will undergo significant changes. However, this warming differs from the current climate crisis. Our current climate crisis is a rapidly accelerating phenomenon driven by human activities and directly linked to global warming. The Sun's increasing brightness, on the other hand, is a natural evolutionary change occurring over millions of years. This process will have far greater and longer-lasting effects than the climate change we are experiencing today. Eventually, carbon dioxide levels are expected to decline significantly. This is crucial for plants, as carbon dioxide is an essential component for photosynthesis. As these levels decrease, plants will struggle to survive and many species will perish. C3 plants will be unable to sustain themselves due to low carbon dioxide levels, while more resilient C4 plants, particularly those like corn and sugarcane, have the potential to survive for another 500 million years. The existence of such plants will lead to a significant transformation of the ecosystem. The extinction of plants will directly lead to the extinction of animals that depend on them for food. The disappearance of animals will cause the collapse of the ecosystem chain, resulting in a general decline in living organisms. Ultimately, oxygen levels will decrease, and only microbes capable of surviving in oxygen-free environments will remain. This marks the end of life on Earth. These changes will occur over vast periods of time, leaving only microscopic life forms on Earth by the end of this process. While these findings pose no immediate threat to our lives today, they are quite thought-provoking. However, we can find comfort in the fact that we have millions of years before this process begins. Nevertheless, the evolution of these processes will be shaped by the decisions we make as a species. If we can mitigate the climate crisis and manage the environment responsibly, we can prolong the existence of life on Earth. By preserving environmental balances, humanity can expand its living spaces and postpone this grand catastrophe. Of course, this can only be achieved through a collective global effort and careful management. The findings regarding the timing of Earth's end demonstrate the impact of evolutionary changes over long periods. However, such scientific research not only provides insights into natural evolutionary processes but also raises crucial questions about how humanity can influence this process and what role we play. Climate change is currently recognized as one of the most significant threats to life on Earth. This crisis is a consequence of human activities such as rapidly increasing greenhouse gas emissions, deforestation, and fossil fuel consumption. The effects of climate change directly impact not only the planet's future but also the environmental challenges we face today. Evolutionary processes like the Sun's increasing brightness, as mentioned in the text, are the result of much longer-term changes, and humans have no chance of slowing down or influencing this process. However, controlling the current climate crisis is crucial to sustaining life on Earth for longer periods. Humans must adopt more sustainable solutions to protect the natural environment instead of destroying it. Efforts such as utilizing renewable energy sources, reducing carbon emissions, and protecting natural ecosystems can make a significant difference for the planet's future. If humanity can embrace an environmentally conscious approach, the effects of the natural changes caused by the sun's increasing brightness can be observed for a much longer period. Another critical aspect is that the end of life on Earth will not only be due to the planet's physical characteristics but also to the preservation of biodiversity. Today, we live in a period where ecosystem degradation and species extinction are at alarming levels, threatening the decline of biodiversity. This not only disrupts the natural balance but also has negative consequences for human health, food security, and economic development. The end of life on Earth will affect not only humans but all living beings, and this process can accelerate if humans fail to fulfill their environmental responsibilities. Finally, the question of when Earth will end carries a significant responsibility for humanity. Are there ways to postpone this process? As technological advancements, scientific progress, and human environmental awareness increase, the possibility of extending the time until Earth's demise may grow. Furthermore, the search for new living spaces in space is becoming increasingly important. Efforts to colonize Mars, plans to transport life to new planets, can offer alternative solutions for humanity's future. However, such initiatives are not only about the end of Earth but also about understanding whether other life forms exist in the universe. While evolutionary processes may seem distant and unimaginable to humanity, the measures we take and the strategies we implement are crucial for the continuity of life on Earth. By effectively managing not only the natural cycle of evolution but also our own activities and the environment, humanity can sustain the quality and continuity of life on Earth for longer periods. The primary cause of the end of life on Earth is the sun's evolutionary process and its effects on our planet. Over time, the sun will become brighter, triggering a change that will significantly alter Earth's atmosphere and ecosystem. The sun's increasing brightness will disrupt Earth's carbon cycle, making it impossible for plants to photosynthesize. The inability of plants to survive will collapse the foundation of the ecosystem chain, ultimately leading to the extinction of all life forms. This change is a natural process that will take millions of years, and its onset is an evolutionary event beyond human control. Another reason is the decline in atmospheric carbon dioxide levels due to the sun's increasing brightness. Carbon dioxide is essential for plants to photosynthesize. The decrease in this level will make it difficult for plants to survive, eventually leading to their extinction. The absence of plants will prevent animals that depend on them from surviving, causing the ecosystem chain to collapse. This will lead to a decrease in atmospheric oxygen levels and ultimately leave only microbes that can survive in oxygen-free environments. In conclusion, the end of life on Earth is caused by the sun's evolutionary changes and their long-term effects on Earth, disrupting the natural balance.